Okay, thank you for joining us. This is the last session of the day on day one. Hopefully I'm not keeping you, or we are not keeping you from the drinks and dessert and stuff that's out there at the marketplace. I'm Azhar Saeed. I'm one of the chief architects in the Telco team at Red Hat. And joining me today on stage is...
Dan Leskarowski. I'm with Affirm Networks. I'm in Director of Product Management, responsible for NFV and cloud strategy with Affirm.
Perfect. So Dan and I today are going to walk you through cloud-native applications in a telco world. What does it mean? And more importantly, how micro do you go? Let's take a look at that. What does it mean? So over the next 40 minutes or so, we'll walk you through different microservices. What does microservices mean? What's the definition? What are the benefits? Why containers as a delivery mechanism for microservices? Why do we want to do that? And then we'll take look at specifically 5G, a driver for cloud-native approach. So what does cloud-native mean in this particular sense? Then we'll look at how an application can be decomposed using microservices. And Dejan is going to walk you through a detailed architecture of how that's possible. In terms of what are the design choices, what's the orchestration model? And we'll wrap it up with a quick summary. So before I go into that, I think just to lay out a little bit of context for all of the telcos, some of you who've been with Red Hat have seen this slide multiple times, and everyone has a unique way of presenting this particular slide. From a telco's perspective, the journey is somewhere between the top left corner to the bottom right corner on this particular slide. And if you take a look at development processes, application architecture, deployment and packaging model, and overall the infrastructure, you're moving from waterfall, rigid, monolithic, physical models to DevOps, microservices, virtual, cloud-based, cloud-native approaches. And that journey is different for different people, but at the same time, everybody wants to get down to that particular point in terms of how do you build cloud-native infrastructure, and then more importantly, how do you take applications and move them into a cloud-native model. So enter microservices. Microservices and containers are a little bit independent of each other. Microservices architecture is independent of containers. It's not necessary to have containers for a microservices architecture. And microservices architecture is all about writing applications so that you can break that application down into different components, and each component has a life cycle of its own. You can use containers to deliver those microservices, so it's a delivery and packaging mechanism for that. People have done breaking down of monolith software, and people used to call them components in the past. People used to call them by different names in terms of how you create subsystems and so on. But what's important here in this particular context is each one is reasonably independent, isolated, and can have a life cycle of its own. That's what we call it as microservice. Now you can take the network functions too. If you take network function as an application, then you can actually move that into a microservices model in much the same way. Every application has different components, right? There's a core component, there's logic, there's database, there is external APIs, there is monitoring capability, maybe some messaging environment inside that particular application. All of them can be peeled apart, and then you can have reusability of those components in different contexts for different applications, thereby providing you much larger scalability in that particular architecture. And then what happens? So what is the real benefit of microservices? Well, you can build smaller, it's a disaggregated function, it's a disaggregated application now. So you have independent, small, autonomous services that can be developed, deployed faster. You can have an automated delivery. You can automate that particular mechanism in order to how do you deliver those different kind of microservices, and provide a high level of granularity, which means that allows you to actually scale as well independently. Now enter containers. Containers are a way to deliver those microservices. A definition of a container is essentially a software packaging concept that actually includes application and its runtime dependencies. It's run in a user space, or it's hypervisors kind of abstract hardware information and present it so a virtual machine can use that. Containers provide an abstraction of the user space but share the same OS and the same network services and the hardware capability of the host. Now, if you take that definition and if you define containers in that way, containers have been around for a long time. Of course, Docker popularized containers, but Linux containers have been around for ages. You can take the microservices and encapsulate them into a container and run that container independently in an infrastructure. So when you have a container infrastructure, when you have an infrastructure that runs different containers, each microservices actually is running inside that particular container, then you can actually take the full benefit of orchestrating those containers, restarting those containers. So you enable better efficiency. You can automate the lifecycle management of it. You can enable much faster deployment in a, from both in terms of development and production. Then you can apply this whole concepts of CI and CD to this particular area. And once you build a container image, then you can run them in different places. You can run them in private cloud, public cloud, hybrid environment on a bare metal node or in a virtual machine. So it can be in any one of those footprints. You can actually run that. Now, we started talking about 5G telco native applications, and then we are starting off with this whole topic of microservices and containers. I just wanted to lay out this context first before we jump into how does that apply to this whole 5G space. So let's talk a little bit about 5G space. 2 slides, literally. I know it's very hard to talk about the entire 5G in 2 slides. So I'm just going to take the 5G space and partition it into 2 capabilities. One is how the radio access network has been evolving, and what does it mean to a 5G space. And 2, how does the packet core is evolving, and what does it mean in the context of 5G. And more importantly, what does this mean in the context of being cloud native towards the end. So that's what we'll come back and wrap. If you take the radio access network, the top line that you see on this slide is your typical deployment model of LTE today. You have E node B, you have a front haul network going to the radio head, and then you have a backhaul infrastructure. That backhaul infrastructure, if there is an MEC deployed, goes through somewhere, say, a mobile or multi-access edge compute node, and then the traffic ultimately hits the packet core. Then now a lot of people have been looking to virtualize some of that RAN infrastructure through deployment of a virtualized baseband unit, VBBU. And then you use different types of front haul for that. So you can use CPRI front haul. Again, it's all latency sensitive because you have radio components that need to be managed. So you can do CPRI fiber, or these days there's an interesting technology using Ethernet front haul to be able to deploy a virtualized BBU environment. That's still 4G CRAN. Now in 5G, what's happening is, because there are 3 different main use cases of 5G, which is URLLC, ultra reliable low latency communication, EMB, enhanced mobile broadband, and number 3 is massive machine type. Now each one of these has different requirements on latency characteristics in the access infrastructure in terms of how you would handle sessions, how would you handle traffic. So with those 3 main use cases, what you have to do now is then split up the virtualized BBU into 2 different areas, something called a CU, which is a centralized unit, and a DU, which is called a distributed unit. The distributed unit is placed much more closer to the radio unit. That's in line 3, if you will, over here. And that distributed unit placement is strictly governed by how latency is managed or mapped, particularly for URLLC type of services. Now, what's important, if you take a look at that in terms of the DU and CU, that both of those are essentially white box hardware, which means it's an Intel type of an infrastructure, which means they're typically compute nodes running control functions and data plane functions. Now, what does that mean? That means you can actually virtualize the central unit, or you can actually, if you have container network functions, you can run, or if you build a microservices architecture for the radio infrastructure, you can actually deploy those microservices out on those CUs and DUs. So that's in the context of RAN. Now let's look at it in the context of packet core. If you look at the packet core has evolved on the top left side of this slide here. And pardon me for the colors on this. That is a box hardware specific capability. So you have MME as a box, you have a SGW as a box, you have a PGW as a box that has all control, data plane capability, everything built in. Then you went a step further and virtualized it, and now you have all of these functions running as virtual machines. Those virtual machines still have the same control and data plane, hence the requirements for all of these fast path stuff, the DPDK and fast path enhancements so that you can do better forwarding, throughput, et cetera, et cetera. Now from here, and that was all running on an OpenStack infrastructure. From here, now there's a new concept that's being increasingly adopted called CUPS, which is control user plane separation. So what you do is you actually take the control plane and run it as virtual machines or microservices or containers. And then you have a data plane function that can potentially be placed in different parts of the network infrastructure. That data plane placement allows you better flexibility in terms of how you model it and potentially allows you better throughput across that particular infrastructure. So that's how the packet core has been evolving. And then finally, if you go to this last picture, that's a completely microservices-based architecture where you have literally disaggregated all of those functions, the AMF, the SMF, and the UPF, which is access management, session management, and the UPF is a user plane function. So user plane function in the 5G NG core architecture, which is to come in release 15, so standard Wendeon, probably approved by June, next month, hopefully. And then you'll start to see some implementations probably later this year. That UPF now can be placed at as close to the radio unit as possible. Remember the CU that we spoke about in the previous slide, or as much in the data center as you require. So there's a level of flexibility that's needed. And okay, if this can move forward. All right, so all those NG core and CRAN stuff places a bunch of requirements on the infrastructure. What are those? The DU, CU, virtualized BBU, all of that stuff, containers can play, or microservices play an attractive role in there. Microservices can be leveraged to build that new kind of software. NG core in terms of different separate control functions that you see, right? You need orchestration models now for those control functions and the data plane functions to be placed anywhere in that particular infrastructure and be orchestrated. There's a granularity of that service. Now, it's not just about building a container network function, or if not just about building a network function and disaggregating it, it's also about when you place a UPF at a remote site, you need the ability to go monitor it. How do you go monitor that particular UPF? What sort of data stats that you need to be able to stream, aggregate, and then create a closed loop feedback control system to be able to go orchestrate. So you need all of those capabilities. Now then add on top of that a use case like network slicing. You asked the question, Neil, on the network slicing stuff. Network slicing is, people have done a way of partitioning their infrastructure through APNs quite a lot today. They already provide some level of a slicing model through APNs. And then you map those APNs to backhaul infrastructure of VPNs, you can potentially create a slice. In 5G, we talk about network slicing in a slightly more different way. What we are also talking about slicing is slicing the radio infrastructure so that you have better efficiencies in terms of utilizing the spectrum, utilizing carrier aggregation, utilizing different kinds of services and reusability of the frequency bands. The requirement on the access infrastructure still remains the same. So ability to map that radio capability back onto the access infrastructure and then create a horizontal slice across that requires an orchestration model that goes all the way from the DU to where your packet core resides. So that's the challenge that it brings up. Now, all of these things, we forgot that we were here really to talk about cloud native. So what does cloud native mean? Let's take a definition of cloud native. Cloud native really, as it's defined by the CNCF, is a stack to deploy applications that are based on microservices, right? And that are dynamically orchestrated and automated. Well, all of that jargon aside on top in terms of descriptions and English language, If you can translate all of that into like few bullets, those are the bullets at the bottom. It has to scale elastically. The application has to be resilient to failures. It has to be instrumented appropriately to provide the right level of insight in terms of what's happening. It must be repeatable, so it should be deployed anywhere, automated, and more importantly, it should utilize cloud principles, cloud storage, queuing, caching, messaging, overall. That's what it means for an application to be really cloud native. And then you have to have a platform to be able to deliver those set of microservices. And then you can measure that particular platform on many different angles and axes. And what you see here on the picture is you need logging and monitoring capability for that application. You need authentication models. You need build deployment pipeline models. You need management capability. You need resilience. You need discovery, and so on and so forth. So in a net, when an application is refactored or disaggregated, you need a PaaS model, which is cloud-based, to be able to go build, integrate, manage, and deliver that together to form a complete service. You probably need some middleware capability. You need some lifecycle management capability of each one of those independent components. And of course, it has to be accessible anywhere. So with this, what I'm going to do is hand off to Dejan and let Dejan talk about how we can take an application. He'll give you an example and see what does cloud native mean and how we can do that. So Dejan, over to you.
Thank you. I'll take the clicker.
Sure.
All right. So I think Azar did a real good job to kind of introduce what cloud native means. Just kind of to step back, for those of you who may not familiar with Affirm, we are fully virtualized Evolved Packet Core. So just like Azar was saying, the evolution of Evolved Packet Core started with virtualization. Yes, there was legacy stuff before, but where we started was with virtualization. All those components were virtualized, running in VMs, 4G. Kind of the transition was into CUBs. You can say it's 5G ready. Everybody has a little bit of a different definition of what CUBs means and even slicing. And then where are we moving? So there's multiple terminologies being thrown out: cloud native, next gen core, 5G. Although they are different definitions, they kind of intertwine together. So Azar had a slide on what was next gen core and the different components of next gen core. And just by moving to next gen core, meaning taking the AMF and the UPF and saying, okay, I'm going to put in a VM, maybe you're solving one part of the equation, but the idea is to kind of take microservices and cloud native and kind of put them together. So really, that's kind of the evolution. If I don't know how many in this room are from the telco space, but if you kind of want to see the landscape of where telco is going, that's the evolution of the mobile core. And very similar, RAN does the same thing. I'll speak from experience from the core perspective because that's what Affirm does. So a few things here, and it's interesting. Actually, Azar and I met for the first time today. And yes, we tried to work on the slides together, but it's a great validation that this was slides that Affirm put together. And some of the same objectives that we are looking for are kind of the same objectives that Azar and Red Hat team brought together. So I did not edit the slides, I promise, when I met Azar. So orchestration. Not to take anything away from what we have today with Mano and everything that is being done from orchestration, but really, the idea is let the vendors focus on what they do great, which is the application. The idea behind it is all the clustering of rules and how you deploy the different microservices, how you interconnect them. There's a lot of work being done on the cloud side that we as telco, we can leverage. So there's no, in other words, there's no need to reinvent the wheels where the wheels are working, so to speak. So orchestration is a big piece, and I'll touch on it a little bit later. Platform as a service. So I have a few slides on this, but really the idea here is there's a lot of services that are repeatable across different network functions. We talk about FCAPs, about logging, about KPIs, about tracing. All of those pieces are common across your network functions. So the idea is, can I create a platform as a service that I can piggyback on? Today, to some extent, some vendors do that, but they very tightly couple it with their application, which kind of goes against the flexibility that you're having. So platform as a service is an important thing, and you'll see later exactly what kind of where we're evolving into that. Standardization on APIs. This is very, very important. I think virtualization has done a great job doing in this area. However, there's much, much more to do. So really standardizing on APIs that are common across vendor. This is extremely important. If you're talking about microservices, you may have a federation of hundreds of microservices. You have to make sure they're speaking the same language. If they're not, you have a big, big problem. And there's stateless applications. So I reuse this thing from one of our architects, the kettles and not pads. I don't know if this is a common terminology. I feel bad for the kettle. But besides that part, the idea here is to say, look, in virtualization, yes, the whole idea behind virtualization is to say, look, if a VM goes down, the perceived impact to the end user, it's not there. You know, this is the whole idea of the legacy where you have to have one-by-one redundancy. So virtualization did a great job. However, there was still a lot of complexity that vendors carried in the application. The idea here is if you're stateless, if one, I won't even say cattle, if one service goes down, it does not impact the health of your system. That's really where the cloud providers excel. If for any reason a microservice goes down, there's no need to panic. There's a new microservice will come up because you're stateless. The state machine is maintained outside of the service. So this is, not to, single one thing out. There's all of these components have to work together. But having stateless microservices really, really simplifies the redundancy mechanisms on the packet core. If you're looking at a packet core, you cannot afford failures in your packet core. So you have to make sure you're resilient. And the last thing we talked about, containers. So sometimes you use microservices and containers as in the same sentence. They're two different things. Microservices you can actually run in VM. You can run it in different states. So the idea is containers makes the best fit for a microservice. That's really why they kind of go hand in hand. You'll see we have kind of done multiple things in terms of how we actually deploy microservices, but that's how the containers come in a picture, although they're two individual kind of things. All right, so the next slide, I want to spend a little time on this slide, and then I'll hurry up through my other slides. But this is an important slide because the title of this presentation was, how micro do you go? How low do you go? And speaking from just a vendor experience, there is a trade-off between fine granular and gaining agility and flexibility versus going more coarse granular and not sacrificing on performance. And just to give you the example on the two sides of the spectrum, if I was focusing on FCAPs, I'll pick logging or KPIs, I can go down to very, very, very granular microservices. Why? Because the performance there is not as critical. So I can have very fine granular microservices. What that will give me is, if I have to upgrade a microservice, I can quickly upgrade a microservice. If I go over to the left side, to the U-plane, now you can argue here, just to give you a specific example, a U-plane, you may say, you know what, I need to do charging, I need to learn the flow, I need to do deep packet inspection to learn the application, I need to do GR encapsulation. All of these are functions that you can say, you know what, I'm going to create microservices, and I'm going to create about 5 or 6 microservices in a U-plane because I want that agility, I want that flexibility. Well, that's great on one side. On the other side, U-plane is very, very performance intensive. So now you have that packet going through multiple microservices, and there's a fine trade-off between how granular do I go versus how much can I sacrifice on performance. If I break the U-plane into 5, 6, 10 microservices, now you have a packet going back and forth. So this is the kind of things that people much, much smarter than me at a firm are working on. But the idea is you have the trade-off in terms of there are some microservices, they'll be larger. I know it's a weird thing to say, a large microservice, but there will be some microservices that are larger. And then you have microservices that can be very, very fine granular, and it makes perfect sense. All right, so just kind of a lay of the land. I know there's many more microservices. This is just this keeps evolving even within Affirmed. This is kind of our view of some of the things that we rely on. A lot of the focus, it's around orchestration, FCAP, so the Docker, Kubernetes, Calico. But then things like just Elastic, Kibana, Prometheus, all of those are things that our application must have and requires, but there's no need to run in the application layer. So these are the things that we will rely on to say, you know what? We will rely on the things that these microservices do best, and we will decouple those type of services outside of our application. Again, the benefit is if I need to update logging and I just pick, let's say, FluentBit, tomorrow there's 2.0 version, I can just upgrade FluentBit. I don't have to roll out and tell my end customer that they have to upgrade their entire network because they need updated logging. Again, just a few examples here, just to give you an idea. Moving on to the next slide. So we mentioned network slicing. This is a little different. I purposely kept this slide here. Within a firm, we have entertained what we call a platform as a service slice. Again, you can, just to kind of go back, you can kind of look at this and say, you know what, I'm going to deploy all my services, all my microservices into a single large platform as a service. But there may be instances where your cloud-native functions may not necessarily require all the microservices running. So this is just an example where you may have different platform as a service options that each different network function microservice piggybacks on. So on the right, you'll see your application. On the left are the common platform as a service items. So I'll do a little zoom in picture, and I'll zoom out just to kind of close on this. So this is an example where I think there's a pointer here. I'm going to try to do this. On the left side are all the different microservices that will say, you know what, these are the kind of things that will offload to the microservice function. So let's, MongoDB, Prometheus, Fluent for logging. On the right-hand side, though, so now we're kind of moving into what do we do as a firm in terms of decoupling our application into microservices. So Azar talked about a little bit about control plane, user plane. So within control plane, you may say, you know what, I have network function, I have routing function, diameter functions, radius functions that I would like to take out because they're common across all of them. So this is an example where you can actually decouple network routing as a common microservice, protocol handling, load balancing. All of those kind of functions are vital to a Evolve Packet Core, to a next-gen core. So those are type of things that can easily come out and become microservices. And then here, now this can vary from a vendor to a vendor. You have different functions as part of the NG core, the AMF, the SMF, UPF. Again, I talked about the UPF as you may say the UPF may not need to be very, very finely grained in terms of microservices. That's an option of the vendor. But a AMF or SMF, you say, you know what, there's a lot of components that I can break out, and it's okay if they talk to each other. It's a private network, they can talk to each other, but I'd rather have the flexibility versus the performance. And again, these are architectural trade-offs that vendors are making. And the last slide before I kind of conclude on this, I think we're good on time. How do we deploy this? So this was the zoomed in slide. This is kind of the zoomed out slide. So we have your vendor-specific, application-specific microservices. You can deploy directly with Kubernetes over bare metal. Usually what we do today, it's kind of a transition for many of our customers. It's use OpenStack with Kubernetes. So containers in a VM. It's a very, very common way of kind of rolling the ball forward and evolving with operators, or doing a cloud-based architecture, a VM as a service, container as a service. All of those are options because at the end of the day, we're up in the application layer. All right, just last slide here. So a few things, and I know we kind of touched on all of this. Model around domain. From a firm perspective, it's the NG core, the next-gen core, microservices, and cloud native. Culture of automation. So this goes across the board. This is not just orchestration of the cloud service, but also making sure that the services that are on top of the cloud are all fully automated. And I know there's other discussion on this area, but it's also important. Independent deployment of each microservice. Usually, to just add something to this, if you have a microservice but every time you have to update or upgrade a microservice, you have to upgrade 4 or 5 other microservices, you're probably doing something wrong, because there's something dependent there. So the idea is that they're independent of each other, and you should be able to upgrade them. Active monitoring of services, isolation of failures. The isolation of failure we talked about, it's really making sure they're stateless. If something goes down, I don't care. I'll come up and bring another one. I have the database that is stateless. Let's see, log and monitoring matrix, I think I touched on. Again, if there are microservices that do this better, rely on something that was already created. No reason to reinvent the wheel. And the last thing, build, test, release, and run. DevOps model is something that telcos are still learning. This is very important. Microservices will enable this. I don't know if I should say, I came from Nortel. I'm an old Nortel guy. And it took 18 months to release a release, right? And it wasn't just our fault. It was join hands with everyone else. So the idea is not to wait 18 months to do a release. It should be quick. So with that, Azar, I'll hand it over to you.
Thank you, Dejan. I think that was really important to actually talk through how an application can be refactored and how you can leverage microservices across different components and build a cloud-native model. Now, Dejan actually talked a number of things about creating that culture of automation, creating that level of independence, regrouping those microservices. I'll give you one example from my past life. The place shall remain nameless, and the vendor shall remain nameless in terms of where I worked. But I had an opportunity to go through this transition of breaking down a monolith into what we called componentization. Those days, microservices wasn't a really big deal or a big buzzword, so we called it componentization. And what we did was, it was protocol development. So we took all of this network protocols and we split them out into independent processes. So BGP was a separate process, ISIS was a separate process, OSPF was a separate process, FIB was a separate process, RIB was a separate process, and then state management function was a separate process. Great, right? Oh, you'd say, yeah, I can build a fully distributed system, highly scaled environment, works excellent, until we compile the whole darn thing and try to run it on a line card and an RP on the box. It just wouldn't work. Why? Because there was too much of RPC that was going on between all of those different processes just to sync the state. So the question of how micro do you go is really important. And I'm just going to hammer home that point by bringing back to what Dejan actually outlined in terms of where it makes sense. You can have a really fine-grained environment where you have reusability, where you have independence, and where it doesn't make sense, you can have a slightly coarse-grained functions that can be deployed, orchestrated, and managed. And to do that, you need a platform. Remember one other important point that he added. He added the ability to do multi-tenancy, the ability to create PaaS as a slice. So to do that, you need a platform. You need a platform that allows you to actually create that multi-tenant environment, manage those containers, manage those microservices, create that particular catalog, do the reusability, build their entire DevOps type of pipeline, and create a better experience overall. So refactoring a monolith is necessary for building cloud-native applications. Leveraging existing microservices for better reusability is important. Containers can provide a very efficient way of delivering those microservices in terms of efficiency. And the question of how micro do you go, I think, is best by that particular example. I don't need to explain that again. Independence becomes important, scale becomes important, efficiency and lifecycle management becomes extremely important. So microservices then are a basis for building the next generation cloud-native functions, network, in particular, network functions for 5G, be it in the context of CRAN or in the context of packet core, as you just saw from Dejan, very eloquently explained. And of course, there's a platform that's available if you want to try your hands on. You want the open source or open community version of it, go to Origin. Thank you very much.